Hi, welcome to the AWS Machine Learning Summit. My name is Sarah van der Moosdijk, and I'm a Machine Learning Partner Solutions Architect based here in Melbourne, Australia. Now, today I want to talk a little bit about intelligent search, and specifically how we can get more relevant answers out of our intelligent search application. So let's get started, shall we? All right, so businesses these days are generating more data than ever before. This can be in the form of text, it can be various databases, it can be audio, it can be video. But the more data we generate, the more difficult it becomes to find the information that we actually need within this data. So there's enormous pressure on businesses to make use of all of that data that they're generating, to get insights from this data and useful information that can give them a competitive advantage and help them serve customers. And in fact, finding useful information in data isn't just limited to businesses. It's really relevant in every aspect of our society. So let's take a look at some of the specific barriers that make it so difficult to find relevant information in all of this data that we're generating. There's a lot of barriers on this slide, and I'm not going to go through each one of them, but let's maybe just take a look at a few. So a lot of our old search solutions, especially within businesses, are still based on keyword search. You put in a couple of keywords and the search will return a list of documents that are relevant to those keywords that you put in. This is fine if you have a general idea of what you're looking for, but when you have a very specific question that you're trying to get answered, generally the keyword search isn't fine-grained enough, right? You still have to go and click on the documents that it recommends and read through to find the actual answer to your specific question. So keyword search is good in some situations, but it can be a little bit too limited to really find the specific information that you're looking for. Another barrier that we often see is that all of this data being generated by businesses, it's scattered across many different data silos. You'll probably have various databases owned by different teams. You might have wikis, you'll have documentation in yet another place. Some of the documentation might be in your code repositories, hidden in amongst the code or in READMEs. So all of this data can be very spread out throughout the organization and owned by different users, which means it's difficult to build one search application that really is able to look through all of that data and get you the answers that you need. Another challenge is that a lot of this data is unstructured. I've already mentioned text and video and audio data, and it can be very, very difficult to actually extract intelligent information out of that. And we really need machine learning to achieve that kind of searching through unstructured data. And then the final barrier that we'll just talk about really briefly is keeping your content up to date. And this is related to the data silos. If your data is spread out across many different silos, it's probably also updated at a different frequency. Some sources might be updated on a daily basis, others might be updated once every couple of months, right? So it can be very challenging with your search application having to pull from all of these sources and having to make sure that it stays up to date with all of these sources so that you're always searching on the latest version of your data. Right? So to solve a lot of these problems, AWS has developed a service called Amazon Kendra. Now, if you're familiar with our AWS machine learning stack, it looks like this. We have 3 layers. The bottom layer is for the experts. That's for people really building, their own custom neural networks. The middle layer is Amazon SageMaker, which is our end-to-end data science solution. And then the service we're talking about today, Amazon Kendra, it sits in the top layer. So the top layer are all of our services that are pre-trained. They make it very easy to get started with machine learning, even if you don't have a lot of background or knowledge in the machine learning field. So a lot of these pre-trained models, the only thing you have to be able to do is make API calls in order to make use of them and integrate them with your business application. And Kendra is a great example of this. So it sits in the top of the stack because it's fully pre-trained and it's very easy to integrate with through API calls and SDKs. So let's look at Kendra in a little bit more detail. All right, so if we talk about Amazon Kendra, right, it's an intelligent search service developed by AWS. And we'll start by looking at the left side of this slide a little bit. So I was mentioning with the barriers that one of the barriers we encounter is that many search applications only provide keyword search. Now, Kendra is built with machine learning models, deep learning models under the hood that also allow you to perform natural language queries. So that means you can ask your question in natural language, right? This could be a what, a who, a where, a how, those types of questions. You can type them out in full natural language, and Kendra will actually search through your documents to find the specific answer to your question and will then surface that answer for you, in addition to providing all of those relevant list of documents that a traditional keyword search will provide you. So Kendra supports both. It will do the keyword search, but it will also allow you to ask your questions in natural language and find your answers a lot faster than you would if you were doing keyword search and had to read through the documents yourself. Another advantage is that these machine learning models, these deep learning models that sit behind Kendra, they've been trained on 14 different domains and industries. So Kendra understands the language that's used within your industry, let's say, healthcare industry or financial services industry. And this really helps Kendra to provide more relevant answers to your specific questions based on your domain. And then the final thing on the left box of the slide is the continuous improvement. So I'm not going to dive into this too much. We do have a mechanism for continuously improving these deep learning models, and we'll actually dive into that deeper later on in this session, so I'm going to skip over it quickly now. So to close off this slide, let's focus on the right side of this. Kendra is very quick and easy to set up. You basically point it to all of your data sources and it will create an index out of those documents, right? Now, your documents might be in many different types of data sources, and we have various connectors to help you link Kendra to these various different sources. And we'll talk a little bit more about that later. But it's very easy to set up. It's very quick to do. You can do all of it through the AWS console. So that's definitely a major advantage of this. And then the final point that I just want to make is in terms of security. So Kendra does have quite a bit of security already built in. Data is always encrypted in transit as well as at rest. And it also provides token-based access control, which basically means that when a user makes a query, it can pass a user access token, and Kendra will filter the search results based on what that user has access to, right? What that user is allowed to see. So there are various layers of security that Kendra already has built in that make it easier to make sure that you tick all of those security boxes when you're building your application. All right, so I already mentioned the difference between sort of the traditional keyword search and the more intelligent natural language search. But I just want to really give a better example of this through these screenshots here. So on the left, you'll see, I guess, what is a typical intranet search, internal company intranet search that we see in a lot of companies. It's just your typical search bar where you can put in keywords, and then what you receive back is a list of relevant documents with the most relevant documents being ordered at the top, right? You have to click on those documents and read through in order to find the answer to your question. Now, on the right, you see what the difference would be with natural language queries. So here you can see an example where we're asking a full natural language question. Where is the support desk? The IT support desk. And Kendra will give you an answer right at the top. So it's found a relevant document. It's looked through that document. It's found the specific answer, which is the first floor, and it will then return that answer to you, as well as telling you where it found that answer in case you want to go and read up more information. Below that, you can see frequently asked questions. So that's another feature of Kendra where you can put in your FAQ, your structured FAQ, and Kendra can also search through that to find the answers to natural language questions. Now, this screenshot doesn't show it, but below that, you'll also still have the traditional list of relevant documents. So if the answer wasn't what you're looking for and you just need that list of documents so you can go read and do research yourself, you will also definitely receive that. So I hope that makes sense in terms of the difference. Right, so let's talk about what are the steps to setting up a Kendra intelligent search application, right? The first step that you have on the left is your data ingestion. So gathering all of your data sources, identifying the different data silos that you have, and then connecting Kendra to it. I already mentioned the connectors. So Kendra has about 50 native connectors or connectors built by partners for various different data sources, right? You can think Salesforce, you can think SharePoint, you can think Drive, S3. So there's lots of these connectors already available. If you do have a data source that we don't support yet out of the box, then you can also create your own custom connector. So it really should be possible to connect to any type of data source that you want. In addition to that, you may want to enrich your data before sending it to Kendra. You might want to do some translation of your documents if you have documents in various languages, or if you have audio, you may want to transcribe that. If you have images, scans of documents, you may want to extract the text from that in order to put it into Kendra for searching. So you can also do that type of enrichment with the other AWS services that we have before you send those documents to the connectors to be indexed by Amazon Kendra. So that's the data ingestion. Now the middle part is optimizing your results. So once Kendra has indexed all of these documents, you're basically ready to do a search, right? You can already start searching through your documents at that point. But sometimes you may want to adjust the results that Kendra returns to be more relevant, right? To perform some manual tuning. Now, there's several different options for optimizing your results. We have the incremental learning, which I already mentioned earlier. This happens automatically. You don't have to do anything to use that. But you also have some manual tuning that you can do in terms of boosting, tuning, creating custom synonyms, and those types of options. So generally, after you create an index, you're going to spend some time optimizing those results. Once you're happy with the results, that's when you want to go to the last step, which is deploying your intelligent search application, right? Often you'll want to integrate it with your own website, either internal or external. We provide some sample code to make that easier for you. Another very common use case is to integrate it with your chatbot, so to have an intelligent chatbot that's able to search through your document collection. Contact centers is another very common integration to provide a search functionality for your contact center agents. And then, of course, we have any other SaaS application that may need search integrated with that. So there's many different options there for how to deploy it. Now, for this session specifically, I actually want to focus just on the middle part of this equation. So just how do we optimize the results? What are the different options that Kendra provides, and what kind of effect do they have, right? So that's what we're going to talk about today, is just this middle part, the optimizing the search results. Okay, so I already mentioned that there's several different types of optimization of relevance that you can do. We have the incremental learning, which is out of the box. It's applied automatically, and there's very little you have to do to take advantage of incremental learning. The other option is manual tuning, where you have control and you directly influence the results that come out of Kendra. This happens in the form of tuning, content boosting, and creating a dictionary of synonyms to sort of capture the slang and the language use of your particular domain or your particular company. Now, I can talk to slides for a long time on these, but I think the most effective way of showing this is really just to show a demo. So let's take a look at a demo for all of these features. Okay, so for this demo, I have already created a Kendra index based on white papers and technical guides published by AWS, as well as some pages from Wikipedia related to machine learning. Now, let's take a look at the attributes available for my documents. All the fields starting with an underscore character are reserved by Kendra. You can choose to either use these attributes or ignore them. The fields without leading underscores are fields which I define specifically for this data set. So notice that I have deselected everything except the default options on this page. So let's look at a metadata file for one of my documents in my index. You can see that I choose to use the reserved category field to tag a document as a white paper, technical guide, or article. I use the last updated @ field to record the latest publication date, and I use the source URI field for the location of the original document. The AWS white papers and technical guides have tags based on their subject and industry, so I include these tags as a custom attribute. And I also include a short description of each document as an attribute, as well as an authority field, which helps me tag the publisher as AWS or Wikipedia. So now we perform a quick search, and the Kendra search will work with everything deselected, but you can see this isn't very useful. Users can't click on the titles of the documents to, see the original documents, and they can't customize the search. So let's improve that. Now there are 4 types of fields: facettable, searchable, displayable, and sortable. So let's look at displayable and searchable first. When you set fields to displayable, it means users can see these fields in the UI. So I'm going to try it with the source URI and the last updated at fields. Searchable means the Kendra index will use the field to perform the search. By default, Kendra searches through the text in the title and the body of the document, as well as the source URI. In this case, it might make sense to also have Kendra look through the abstracts of the documents, so the description field. Then if we go back to the Search console and type in the same question as before, we should see a change in the UI. Because we made the source URI displayable, we can now click on the document titles to access the original documents, and we see the URI at the bottom of each result item as well. We also made the last updated at field displayable, which means we can now see these dates in the results. In this case, making the abstract searchable didn't have much of an effect because everything written in the abstracts also already appears in the document body. Now, there are 2 more options that we haven't covered. Notice that we have a sort of drop down in the Search console. Right now, there's only one option. It automatically sorts the results by relevance. We can add more options to this by changing the facet definitions page and making fields sortable. So in this case, it would make sense to have the last updated at field become sortable, so users can sort by the latest publication date. The final option that we have is to make fields facettable. This allows a user to filter the results based on their value. In this case, we can make the category field and the tags field facettable. When we go back to the Search console then and try the same query, we'll see the effects. So first, we can now see that we can sort the results by the latest publication date. In this case, that means the Wikipedia documents will generally end up at the top of the search results because they're updated very often. To filter the results, we can open the drop-down on the left, and this shows us the filter options, as well as how many documents we can expect to find in each category. So if we click on white papers, the results immediately reflect this choice. Now, making the fields facettable and searchable gives the user control over the Kendra search results. But there's a lot you can do for a user as a developer. So let's look into tuning next. When we open the right panel on the Search console, there are tuning options available to the developer of the Kendra index. Here you can boost the searchability of certain attributes. So if we click through the options now, we can see that the boost for every field is 1, which is the lowest option. Now, there are 2 attributes in particular that are often used by customers when tuning their Kendra index. The first is the last updated at field to automatically boost documents that were updated more recently. The second common use case is to boost documents from more authoritative sources. In this case, with Wikipedia being a publicly editable source, we can boost the documents published by AWS. Now, first notice that the authority field we defined is currently not available in the panel. And that's because we actually have to make it searchable first. So let's do that quickly. Okay, so if we head back to the Search console, we should now see the authority field available. So before we apply boosting, let's take a look at the results for the query, why should I use MLOps? The first document in the list is the Wikipedia article on MLOps. So if we want to boost the AWS documents, we need to apply boosting to a specific authority value, not to the field as a whole. So we ignore that first boosting option and open up the advanced settings. We enter the value AWS and set the boost to 7. 10 is the maximum boost value, but you want to test smaller numbers first and sort of work your way up to your desired result. When you save these settings, Kendra recommends that you wait 10 seconds for the settings to take effect, so I'll come back to this. Now, everything I've shown you so far has been done from the console, and the console is fine for demos and quickly testing the effects of different tuning options. But when you're seriously tuning an index for a production use case, you'll want to document the results of your tuning experiments for reproducibility and auditing. The best way to do this is by actually tuning the index through code instead of the console. And we'll take a look at using code a little bit later on in this demo. But first, one other thing I should mention is that in this example, we apply boosting to all users and queries. In April this year, the Kendra team actually released a new feature called Dynamic Relevance Tuning. And this allows you to apply boosting at the time of making a query based on user attributes or other context. So you can imagine if we know that a user is from a technical team, we could boost sources like the internal wiki pages or API documentation. Whereas if the user is from the HR department, we could boost sources like SharePoint and the database of company policies. Now, before we move on, we can quickly refresh the query, and now we see that the AWS published document is actually ranked higher than the Wikipedia article. Okay, our final topic for this demo is incremental learning. So where the faceting and the sorting options give the user control of the Kendra results and the boosting gives the developer control of the Kendra results, the incremental learning responds automatically to the behavior of your users. We'll first understand how it works through the console, and then we'll look at how to test it through code. There are two types of user behavior which Kendra can learn from, clicks and relevance. Users can provide feedback on the relevance of a document by clicking the thumbs up and thumbs down buttons. This is the best indicator of relevance, but not everybody will click those buttons. So another indicator is clicking on the title, and we can assume that a document is relevant if the user clicks on it. So let's look at some code, right? This is code I wrote to trigger incremental learning, and I chose to use the AWS Python SDK to deploy it as a Lambda function, but you can use any SDK of your choice. Normally, when you're testing something like boosting, you define a set of questions to measure the results on. In this case, I've defined just one. Then I use the Kendra API calls to send a query to my index with this question. At its core, it's a very simple API call. The output is a JSON object with all the results returned by Kendra. Now we want to store those results in an S3 bucket with a timestamp so we can compare the results for the same question over time. Again, this is a very simple API call using just the S3 APIs. In this case, I want to trigger the incremental learning feature based on clicks. I use the Kendra submit feedback API call to simulate a user clicking on a particular document in response to this query. Now, it can take up to 24 hours for incremental learning to take effect on the Kendra search results. So I actually uploaded this code you see here to a Lambda function on AWS, and I scheduled that function to run once every 4 hours. So here you see the search results returned by Kendra the first time I ran this code. This is an example of the JSON result that you get back from Kendra, and we can see that the most relevant document, which sits at the top of the results, is called Deep Learning on AWS. When we look at the second file, which is the search results after 24 hours, we can see that now a different document is at the top, which is the Machine Learning Foundations, and that's the document that I simulated the user clicking on repeatedly. So I hope that makes sense in terms of understanding the different options you have for tuning the relevance of a Kendra index and how you can use them to make your search results more relevant to your users. Okay, so let's take a look at a couple of industry use cases for this. Starting with Magellan RX. So you can imagine that in the healthcare industry, there's vast amounts of patient data and drug information, which can make it overwhelming to locate accurate information quickly. Now, Magellan RX was actually able to deploy Amazon Kendra inside of their call center as a tool for call center agents to locate critical patient information as they're on a call with that particular patient. And this helped them boost the efficiency of the agents in the form of the average call time reduction. That was happening on a massive scale. Now, besides the call time reduction, another additional benefit, an indirect benefit of providing this intelligent search application to their agents was that there was a significant reduction in agent training times, and there was actually a boost in agent retention rates. So this was really just driven by the fact that this intelligent search empowers them and enables agents to perform their jobs more easily and more efficiently. So that's one example within the healthcare space. Let's take a look at a completely different domain, right? The Wall Street Journal. So the Wall Street Journal used Amazon Kendra's intelligent search capabilities in Q4, so latter sort of the end of 2020, for their Talk 2020 tool, which was live on their website for the 2020 presidential elections. So this tool gave voters and visitors the ability to ask natural language questions, plain language questions about each of the presidential candidates and their positions on specific policies like the economy or climate change. So this tool was really useful because it allowed users to ask questions in a very natural way, and to ask questions that are relevant to them and that they find important when, choosing or looking at the different presidential candidates and deciding who to vote for. So just building this tool and making it available was a very great way of searching through all of that information on these various candidates. The final case that we'll take a look at is the Department of Labor and Training of Rhode Island. And they were facing a lot of issues when, unfortunately, COVID hit in 2019 and 2020. So when COVID hit, their inbound queries spiked. They suddenly got a huge volume of queries from state residents looking for answers related to unemployment benefits, and general questions about labor and employment related to COVID. So it was very difficult to handle this immediate spike in queries that were coming in. And what the DLT did is they deployed Kendra as part of their chatbot. So I already mentioned previously that this is a very common use case to actually integrate the search with a chatbot and basically give customers a self-service tool that they can talk to, they can answer questions, and this chatbot will then intelligently search through the whole document collection to find the answers that people need. Now, just on the very first day that it launched, this tool was already used by 85,000 citizens of Rhode Island. So it was definitely a very popular tool to use. And with that, I hope you found this a useful presentation. I hope it will help you use Kendra even better, get even more relevant answers out of your intelligent search. Now, if you're not sure where to get started with Kendra, we do have various options. We have solutions architects like myself who can help you get started. But we also have the ML Solutions Lab, which is a team of AWS experts that can help you build a POC with Kendra. We, of course, have our partner network. As a partner solutions architect, I definitely can recommend working with partners. We have lots of very good partners that can really help you set this up for your business. And of course, we have a lot of documentation, tutorials, and code samples available. Now, if you're not sure where to start on machine learning as a whole, if you're quite new to machine learning, we do have several different machine learning courses available. There's a certification that you can get, a machine learning certification that proves that you have the knowledge of machine learning on AWS. And of course, you can continue to watch other sessions in this summit to also learn more. And with that, I'd like to thank you very much for taking the time to listen to my session today. I really appreciate it. And I'm just going to ask for one final favor, which is that you complete the session survey. It really helps me to know what you thought of the survey and what we can do to improve in the future. So yeah, thank you very much, and I hope you enjoy the rest of AWS Machine Learning Summit.